Giant auto companies like Toyota have dominated the industry for decades, not only because they make cars for every budget and taste, but also because their engines are among the best. Their new hydrogen fuel cell engine is big on carbon neutrality and efficiency, a quality the entire industry has been clamoring for. Toyota has a long history of producing engines, dating back to the 1930s. In the early days, they produced engines for their vehicles and those of other manufacturers. But today, Toyota engines can be found in various vehicles, from compact cars to trucks and SUVs. In 2015, Toyota announced the Environmental Challenge 2050, which aims to reduce the CO2 activity for the whole vehicle life cycle, from production, vehicle usage, and recycling. Their vision is that environmental vehicles are only meaningful as environmental vehicles if they become popular and contribute to CO2 reduction. To reach these goals, Toyota's investing in the development of electric vehicles, hydrogen fuel cell technology, and renewable energy sources. To advance their course, Toyota's introduced a new engine that runs entirely on hydrogen and emits water vapor instead of carbon dioxide, thereby offering a more green and sustainable alternative to fossil fuels. In this video, we'll get into what this technology means for the car industry and car owners, as well as its viability and limitations. Stay tuned. One thing that sets Toyota apart from other car manufacturers is its commitment to innovation and technology. They were one of the first companies to introduce hybrid cars to the market and continue to be a leader in developing hybrid and electric vehicles. Their hybrid system uses a gasoline engine and an electric motor to power the vehicle. This not only improves fuel efficiency, but also reduces emissions. The Toyota Prius, for example, has become synonymous with hybrid technology and is one of the most popular hybrid vehicles on the market. In terms of safety, the Japanese company strongly emphasizes it, with many of its models earning top safety ratings from organizations like the National Highway Traffic Safety Administration. Buyers are drawn to Toyota cars for many reasons, and one is their engine's impressive performance, which stems from the company's focus on engine research and development. The company's journey towards creating top-performing engines began in 1934 with the production of the Type A engine, and despite initial difficulties in creating the water jacket's core, Toyota completed its first prototype engine in September of 1934. The engine was limited to cast parts manufactured in-house, while imported parts were used for crankshafts, camshafts, valves, plugs, and electrical components. However, when the prototype was fitted in a Chevrolet truck, the engine could only produce 48 to 49 horsepower. But after redesigning the cylinder head, the engine reached an output of 65 horsepower, which exceeded that of the Chevrolet. From that time on, Toyota never looked back. In 1992, the Japanese company started researching fuel cell engines, but it wasn't until 2013 at the Tokyo Motor Show that the company presented its first hydrogen-powered fuel cell concept car to the public. The vehicle took roughly 3 minutes to refuel, about the same as a gasoline car, and the fuel cell system was equipped with Toyota's high-efficiency boost converter. It also featured a fuel cell system with an output power density of 3 kilowatts per liter, delivering an output power of more than 100 kilowatts, and used Toyota's proprietary lightweight fuel cell stack and two 70 megapascals high-pressure hydrogen tanks placed beneath this specially designed body. The 2021 Toyota Mirai took FCEV technology to another level. Combined with innovative packaging and better aerodynamic efficiency, it increased the driving range to almost 650 kilometers with no emissions other than clean water. Before we get into further details, let's explain what a fuel cell engine is. A fuel cell engine is a device that converts chemical energy from a fuel, like hydrogen, as in the case of Toyota, into electricity through a process called electrolysis. The electricity generated can then be used to power an electric motor, which can drive a vehicle or other equipment. Fuel cells work by having two electrodes, an anode and a cathode, separated by an electrolyte. The fuel, typically hydrogen, is supplied to the anode, where a catalyst causes the hydrogen molecules to split into protons and electrons. The protons can pass through the electrolyte to the cathode, while the electrons are forced to take an external circuit, creating an electrical current. At the cathode, oxygen from the air is supplied and reacts with the protons and electrons, creating water and heat as byproducts. One of the main advantages of fuel cells is that they're highly efficient and produce little to no pollution, as the only byproducts are water and heat. They also have a high energy density, which means they can store a lot of energy in a small space. This makes them ideal for use in vehicles, as they can provide power for the electric motor while taking up less space than traditional internal combustion engines. The Mirai did not perform so well for many reasons, so Toyota had to devise a new way of using hydrogen to power their engines. this time not as a fuel cell, but as the fuel in a combustion engine. The difference is that the fuel cell is an application of hydrogen as an electrochemical substance, not a combustible fuel. The hydrogen internal combustion engine is a modified version of the traditional gasoline-powered internal combustion engine and was born out of the 1.6-liter turbocharged 3-cylinder already seen in the GR Yaris and the GR Corolla. What Toyota did was modify the 1.6-liter turbocharged 3-cylinder with the addition of a heavy-duty fuel tank to contain the hydrogen under high pressure and develop a new prototype hydrogen internal combustion engine car called the Corolla Cross H2 concept. This means it doesn't work like any internal combustion engine. For instance, thick, armored fuel tanks are used for holding the hydrogen technology because hydrogen is a highly flammable gas. The car engine is also modified to include hardened valves and valve seats, stronger connecting rods, and fuel injectors designed for gas, not liquid. All of these modifications are intended to prevent hazards that could arise from the flammable nature of hydrogen. The engine works by mixing hydrogen gas with the oxygen in the combustion chamber, where it's ignited by a spark plug just like a traditional gasoline engine. Toyota's announced a partnership with Yamaha Motor to develop a hydrogen-fueled V8 engine that'll produce 455 horsepower and 398 pound-feet of torque. The V8 engine will also have a distinct high-frequency sound due to the 8-into-1 top-mounted exhaust manifold. One of the main advantages of a hydrogen combustion engine over a traditional gasoline engine is that it produces zero emissions. Instead of emitting harmful pollutants like carbon dioxide and nitrogen oxides, the only byproduct of the combustion process is water vapor. This makes hydrogen combustion engines an attractive option for reducing emissions in the transportation sector. Another advantage of hydrogen combustion engines is their high energy efficiency. Because hydrogen has a higher energy density than gasoline, these engines can convert more of the fuel's energy into useful power. Additionally, hydrogen combustion engines can be designed to have a higher compression ratio, which further improves their efficiency. This also means that the vehicle reduces the use of limited supply materials like lithium and nickel, critical components in EV construction. Despite these advantages, there are also some challenges associated with hydrogen combustion engines. One major challenge is the lack of infrastructure for hydrogen fuel distribution. Unlike gasoline, hydrogen must be stored in high-pressure tanks and distributed through a specialized fueling infrastructure. This infrastructure is currently limited, making it difficult for hydrogen-powered vehicles to be widely adopted. Another challenge is the cost of producing hydrogen fuel. Currently, the majority of hydrogen is produced from natural gas, which is a fossil fuel. This means that hydrogen fuel is not yet a truly renewable energy source. However, research is being done to develop more sustainable hydrogen production methods, such as using renewable electricity to power the electrolysis of water to produce hydrogen. Also, hydrogen fuel is an alternative to traditional fossil fuels and is considered a clean energy source because it produces water vapor instead of harmful emissions. However, it's not completely emission-free. When burned, hydrogen can produce oxides of nitrogen, known as NOx, which are pollutants. Increasing the amount of oxygen can reduce the amount of NOx emitted, but that'll mean gasoline combustion engines have that edge. Consequently, a bigger engine will be required to generate equal horsepower as a petrol engine that comes for a lower price. The hydrogen combustion engine is not entirely Toyota's brainchild. The concept's been around for a long time, but one of the most successful was in the early 2000s, thanks to BMW. The BMW 7 Series E65 featured a variant that ran on hydrogen rather than gasoline or diesel. It was produced in 100 units and was shown to the public as a type of experiment, demonstrating that hydrogen can be used on passenger cars. The Hydrogen 7 had two tanks, one for hydrogen and one for gasoline. The hydrogen fuel was stored in a large, nearly 170-liter, bi-layered, highly insulated tank that stored hydrogen as a liquid, which offers 75% more energy per volume as a liquid than compressed gas at 700 bars of pressure. The hydrogen tank's insulation was under high vacuum in order to keep heat transfer to the hydrogen to a bare minimum. While BMW claimed zero emissions, the EPA disagreed, claiming that the engine used in the prototypes was still an internal combustion engine unit, and so used lubrication, which meant that small particles of oil could get into the combustion chamber. As a result, the Hydrogen 7 was not recognized as an emission-free car. BMW was so disappointed with how the EPA saw its project that it abandoned it entirely. As we race towards net zero, fuel cell vehicles will gain popularity, and we'll see these reoccurring patterns emerge. With time, engineers may be able to find permanent solutions to the problems that plague hydrogen combustion engines. Considering how expensive the overall process is, do you think Toyota's hydrogen combustion engine's worth it? Tell us what you think in the comments.